3G network, the biggest node that you need to love, that you need to work on. I mean, if you are a 3G run guy, your node is the RNC. Sometimes you are called the RNC engineer because you do everything there. So the controller is the radio network controller, which is the RNC in a 3G network. So there's a link between every node B on the network and the RNC. So if there are 10 RNCs, if there are 10 node Bs on the network, there are 10 IUB links. If you connect to the RNC, you see all the links there. If there are 100 node Bs, which are being controlled by the RNC, you will see 100 IUB links, right? Because the interface between the node B and the RNC is called the IUB. So this is key. Okay, now on the RNC, it is connected to the core network on two interfaces. One interface is going to the MSC or the CS core, and the other interface is going to the packet core or the SGSN. Okay, now the interface that is going to the CS core is called the IUCS. So it's easy, IUCS. The other interface that is going to the packet core is called IUPS. That's the packet service. So that is to the core network. Yeah. Now, in every network, I've not seen a network where we have only one RNC. Let me see, even Guinea-Bissau. Okay, I think the only network I've worked on where there was only one RNC was Guinea-Bissau, because Guinea-Bissau is a small place, so they don't have more than one RNC at the time. I don't know for now, maybe they've added another one. Okay, so you will see that in every network you have more than one RNCs, and they need to talk to each other because they also need to manage mobility of users. If one guy is in a cell which is being controlled by one RNC, maybe AT-RNC1, and is moving to a cell that is being controlled by maybe AT-RNC2, AT-RNC2 should know so that the handover can be done seamlessly, so that the call doesn't drop. You know, it's annoying when you're talking and your call drops, or when you're browsing and you go offline because of these network, you know, inconsistencies or issues. Now, so anytime you're defining a new RNC, you need to define an IUR interface between the two RNCs. So any RNC you want them to talk on the network, you define IUR interface. So the interface between two RNCs is called IUR. Exactly. And then there is this MUB, which is going to the MUB interface is actually for O&M, which is connecting to the OSS. The OSS is the central point where you can sit and connect to every node on the network. That's the OSS. So the MUB is connecting to the OSS. I mean, so if you're on the OSS and you want to connect to a node B, the interface you're connecting is the MUB. If you want to connect to the MUR, if you want to connect to the RNC from the OSS, the interface is called the MUR. Yeah, but that is the MUB and the MUR normally are not part of. They are not really part of the RAN architecture. But of course, you need to connect for maintenance purposes. Okay, so we can move to the next slide. Okay, so this slide is talking about what I've already talked about. At this point, I want to pause and then take some questions. Let's ask some practical questions. I mean, then before we move on.
Yeah, Ebenezer.
Yes, sir.
So, back to the diagram. Okay, you are RNC engineer, right?
Exactly.
I don't know if what I'm about to say is correct, but I learned that, or I feel like much attention is given to the IUB. Why?
Okay, much attention is given to the IUB because
interfaces.
Come again.
like as compared to the other interfaces like the IUR and then the rest.
Exactly.
Like
exactly. You're right, because you know the IUCS and the IUPS, that's what we call the northbound. Normally, you can be a run engineer, and for a long time, if you are not careful, if you are not lucky, you might not even have the chance to configure anything on that side, because this is normally done when the RNC is being integrated into the core, and you do it once, right? If it's a new RNC, that's when you get a chance to integrate. So there are a lot of run guys, they've not had a chance to play with these, I mean, configuration regarding the the northbound or the IUPS and the IUCS, because once they are connected or configured already, nobody touches it. Because if you make a mistake and you go and delete some signaling links going to the MSC or SGSN, man, you can be in hot waters, right? It means that all the sites are going to go down, I mean, after some time. All the sites which are connected on the IUB are going to be affected, because you have disconnected, or you've created a problem between the RNC and the core network. Okay, so normally the IUCS, the IUPS, unless there's an issue, where you look at it, it is mostly the IUB, because every now and then there are new sites which are being added to the RNC, and they are on the IUB interface, right?
Okay.
Do you understand? So mostly you see that on the IUB interface, you do a lot of work, even if it's a new rollout. Once you integrate the RNC into the network and the signaling links are up, you know, you've done the test and everything is okay, you leave it as it is, right? Even though you'll be monitoring it to see everything is okay. Now, majority of your work is going to be adding new sites to the RNC, right? So, and every site you add, there's an IUB link to it. So that's how come it's like that, right?
Okay, I get it.
Okay. Do you have any other question? Okay, Max, let's move on, and then let's try to wrap up on this, then go to we have the 4G also to talk about. I think the 3G is quite okay. Okay. So the Node B is like the BTS in 2G, and the Node B provides a physical link between the UE and the network. It organizes transmission and reception of data across the radio interface, and also applies codes that are necessary to receive channels in CDMA systems, I mean WCDMA systems. Okay, so let's go to the next slide. So the function of the RNC, I mean, we have talked about it already: core admission control, radio bearer management, mobility management, congestion control, operation and maintenance, tax, you know. So these are stuff we can just read, and then we get to know them, yeah, as the functions of the RNC. But as an RNC guy, you do more than just knowing the functionalities. You see how you configure the functionalities. Let me say that you configure the functionalities. I mean, I'm praying you have the chance to see how all these things work in a real life, I mean, network. Yeah, because that is the motive, and that is what Televersity is all about. We want to give practical knowledge to all of us, so that we will know how all these things work in the practical sense. Okay, Max, let's go on. Let's go on to the next. I want us to round up with a yes. So the E-UTRAN, that is the 4G. That is the 4G network. E-UTRAN is the 4G network. The 4G network is very interesting. When the 4G was coming, we thought it was going to be more complex. So there were lots of guys in the industry who were jittery. So how is the 4G going to look like? Because we've seen 2G, we've seen 3G. Now we're going to have 4G. Then we got to know that 4G is going to be simpler because you've taken the controller out of it. The 4G doesn't have a controller, right? So when you look at the E-UTRAN architecture, there's no controller. You will not see any node like the RNC or the BSC in it. From the site equipment, which is the E node B. So the BTS in 4G is not called node B, it is called E node B. That's how we call it, E node B, E and B, E node B. So from the E node B on site, we go straight to the packet core. Another interesting thing about the 4G network is that it doesn't connect to the CS core directly. It doesn't connect to the CS core directly. It connects only to the PCN, that's the packet core, because the intention of the 4G is that we want to enhance the data services so that we can do a lot of these data services at a high speed, right? So if you're on the 4G network and you are receiving a call, somebody is calling you, you need to move. You will be moved from the 4G to a 3G or 2G network before you can receive the call. So that is what we call CS fallback. You're falling back to the CS service because on the 4G, there's no CS service. There's no circuit switched service on the 4G. So, for instance, if you are on the 4G network and somebody is calling you, is giving you a voice call, a typical CS call, we have configured everything such that you will be moved you'll be handed over from the 4G network to a 3G RAN or 2G RAN, so you can do your CS call. When you finish, within maybe 2 seconds, you're supposed to come back to the 4G. You're supposed to return to LTE. Yeah, so in any way, another name for 4G is LTE, right? LTE, sometimes we call it LTE, long-term evolution, you know. Yeah, so okay, so we're going to round up with the 4G, but I love the 4G architecture because it's simpler, and then we will end here, but let me round up here. Okay, so let's look at the interfaces, the various interfaces. It looks a bit clumsy, but we will try to explain them from the RAN side. So from the E node B, we're going to the SGW, right? The SGW is one node on the packet core, right? And the interface is S1. Now, there are two types of S1. Physically, the channel will be the same, right? But logically, you have S1 user plane and S1 control plane, right? Normally, control plane is for signaling, and the user plane is where the payload or the traffic itself goes on. So the S1 user plane goes to the SGW, which is also a node on the packet core. Okay, then the S1 control plane goes to the MME. The MME is, to my knowledge, it was like the SGSN, and which have been upgraded or modified, yeah, to be known as the MME. That's the mobility management entity or something like that. Yeah. So there's the S1 control plane, which is for signaling, connects the E node B to the packet core on the MME. Okay, so now between E node Bs, they need to communicate. So there is an interface for communication. Physically, it will be just one, biologically, we have the user plane and the control plane. So that interface is called X2 interface, but we have X2 user plane and X2 control plane, right? But you can just say the interface between two E-node Bs is called X2 interface, right? And of course, these S10, S11, these are interfaces on a packet core. But of course, if you know, it's a plus for you. The S10 between MMEs, S11 is between the MME and the SGW. That's the S5/S8 is between the packet gateway and the serving gateway. These are all core nodes. Yeah. So basically, for the 4G network, or the E-UTRAN network, the only node is the E-node B. That's what you'll be working on as a RAN guy. You'll be working on the E-node B, which is on site. Yeah, but of course you have OSS connection or ONM connection to it. Okay, Max, let's see the next slide, and then we round it up and take some questions. So this architecture access network comprises only one network element called the evolved node B, right? Which is the E-UTRAN base station. It includes UMTS base station, BTS, you know. Okay, so let me say here that even though traditionally the 4G network was made for data, there is also another technology which was added to it to make it possible for you to do voice calls on it. That is the voice over LTE, or the VoLTE. Yeah. Practically, I've seen very few telcos which have these functionalities in their 4G network. And in Ghana, it's only MTN that I know of. MTN is the only network which applies the VoLTE, which is the voice over LTE, where if you have a VoLTE capable phone and you're connected to the 4G network, you can make calls or voice calls on the 4G network without being falling back on the 2G or 3G network. Okay, so let me just chip in that. Okay, so the LTE node B is a fully distributed radio base station. So here what it is the functionalities of the RNC have been added to, or some functionalities of the RNC have been added to the E-node B on site, and some have also been given to the SGW and the MME, which happens to be on the core network, packet core network. Let's move to the next slide. Okay, so the RAN architecture questions. So these are questions you can just go through, and I'm sure if you followed, you should be able to answer these questions, like two functions of the RNC, two major differences between E-node B and node B, and the part of GRAN network that houses the radio transceiver, that defines a cell and handles the radio link of protocols with the MS is called, you know, this is the BTS. Okay, so we're going to end here, but maybe we take some 5 minutes. Max, do we have some 5 minutes for some questions?
Yeah, yes. Let's try to, round it up, because Godfrey is also waiting to do his.
Godfrey is also waiting.
Yes. Yeah.
Okay, guys. So I guess
maybe 1 minute, 2 minutes, we can ask the questions, and then we can move on to the next presentation.
If I may ask, when you were discussing about the 4G architecture, it looks like there is much priority is given to the circuit switch fallback when you are having a packet switch connection. Why is this so? Take, for instance, you are having a call, and then the circuit switch call comes in. You fall back to the 2G or the 3G network you are connected to. So why is priority given to that?
Okay, the priority is given to that because if you don't move to these networks, you cannot connect your voice call. Your voice call will not be possible because the 4G doesn't have that connection to the CS core. I mean, do you understand?
Sorry, there is a connection to CS core, but via IMS network, not via all network. There is no possibility
directly.
If you have IMS network, yeah, but there is a possibility to connect voice network to PS network.
Yeah, so that is but we are talking about from the RAN side.
Possibility. Sorry, there is two possibilities. If you have IMS network, it's okay. You don't need the CS fullback. But if you don't have IMS network, you need to activate this functionality to allow people connected to 4G to be able to make a voice call. That's the difference between 3G and 4G.
I am not talking about the IMS architecture, like introducing IMS. I'm talking about when you have only the 4G.
No, I'm not talking about you. No. I'm talking with the with the instructor, because he said there is no voice network connected to 4G. There is core network connected to 4G, which called IMS network.
Okay.
But in case there is no IMS network, we activate CS fullback to allow people to make calls. That's all.
Okay, exactly. So that is what he was asking. That if you're not connected with the IMS network and you are only connected to the PCN, he's saying, why should you necessarily move to 3G or 4G? I mean, or 3G or 2G, right? And that's what I'm telling him, that if you don't move to the 3G, then you cannot make the CS call. So necessarily you need to be moved, so that there are reselection configurations which are done on the 4G node and then also on the 3G node, so that, I mean, whether the 3G is priority or the 2G is priority. Some networks prefer the 3G to be the priority CS network, and then before the 2G also coming. Yeah.
Okay, thank you.
Yeah. Do we have any more questions?
Hello. Hello, guys. Hello.
Hello, Max.
Yeah. So, I think we are okay with the RAN presentation. Since no more questions are coming through, we would be moving to the RAN. The transmission presentation. So, just hold on a little bit. I think we have two more presentations to do right now. We have the transmission, and then finally we'll do the IP presentation. So we have Godfrey on the call. Godfrey, are you ready to take the presentation?
Let's give ourselves some 5 minutes to.
Okay. All right. Okay. Okay. Sure. Okay, so we have a 5 minutes break recess, then we come back.
Okay.
Thank you, guys.
Welcome.